Okay, it
Hi
is.
everyone, welcome to the uh, Python programming, basic Python programming. It is called PP101. This is part of a larger machine learning using Python, uh, which is starting on the 16th September. This is a prerequisite for the ML using Python. So this is a basic Python programming called Python programming PP101 and compiled and delivered by Jamie Tosawa. And with that, I will hand over to Jamie. Yeah, go ahead and start from the beginning. Thank you.
Yeah. So, hello everyone. This is the first session for basic Python programming, which acts as a prerequisite for the ML using Python or machine learning using Python course that we have started from 16 September. So this basic Python programming course is going to make aware or get the required skill for a person to get started Python programming for their own use and uh, explore the possibilities where they want to go, whether it's a web dev or something. But it will definitely make sure that it enables you in the world of Python. And this particular course is designed for as a prerequisite. So we'll be using and learning Python for the machine learning part and the basic Python for it. So the contents of this basic Python programming course are going to be the introduction to the variables, numbers, strings, both, or the data types that exist. Then the language rules, how the naming convention works within Python. Then the white spaces and the indentations that are very important as then working with the collections like lists, tuples, and dictionaries, which are extensively used when Python is uh, used with SQL or any kind of databases. Then the control flow statements, the if, for, and stuff, the loops and stuff. Then the string operations, how strings can be manipulated and used in our accordance. Then the functions and methods, using the already defined functions to custom functions. Then the maps and filters for using those functions and methods that we have used on an iterables. The maps and filters are used. Then learning about the modules and packages. The modules and packages, they can be also be customized and used or have a user defined taste to it. So how to make your own customized modules and packages. Then a list comprehensions for a shorter execution of it, and also the lambda functions or anonymous functions. So these will be the topics that will be covered within the 6 whole sessions. So let's get started with the variables. So we have already used variables in mathematical equations and stuff to store a value or find a value of the variable, uh, which we don't know of. We assign a value to it, we assign a name to it, and then eventually solve the equation in order to get the value of the variable. But if I use a different analogy to introduce variables, then let's say that there is a box, and that box can contain something within it. So, and also we can name that box. So let's say we are just calling it a box for the time, and we store a value to it. Then that box will contain that value. The same way, we can name that box too. So let's say the first, let's start with the first, where the name of the box is A, and the uh, and the something that the box contains is its value. So the value within the box is called 10, is a 10. In similar way, we can call the box B, and we can store the word hello within the box, or a string. So, so the words or sentences that are used within the programming languages, they are often called as strings. So we are naming the box B and storing the value hello. Or we need a much more larger functionality, or a much more larger list, or a key value pair. Then we can use we can name the box with its descriptive name. Let's say World Cup winners of cricket, and then store the values with year, and in that year which team won the cricket World Cup. For example, 1983 India won, in 2007 Australia won, and so on. So you can also save a different kind of collections within the box also. So the variables can be saved in that manner also, like for dictionaries, list, tuples, etc. We'll will cover those topics further also. So as we have discussed a bit about variables, there are certain rules to it and on how we can use variables. So variables are used to store a value. Then a variable can have a short name like X and Y, or A or B, or a more descriptive name like a World Cup winners, or age, car name, total volume, where the name of the variable itself says what the variable contains, or which values of it does it contain. It can be age of a person, age of a car. So we can name the value of the variable, car age, person age, etc. So there are certain rules to it. So let's go through the rules and discuss the valid and the invalid names. So a variable name must start with a letter, or an underscore character. A variable name cannot start with a number. A variable name can only contain alphanumeric characters and underscores. So A to Z, capital or smaller case, then 0 to 9 digits, and sorry, not digits, 0 to 9 numbers, and the underscore character within its name. Then variable names are case sensitive. So you can see the age being written in a three different manner, and those all three of them will be treated in a three different manner in the memory. Then a variable cannot be of any of the Python keywords that are existing within the language. So Python keywords are nothing but the predefined words that are already stored within Python for its own specific use, which have its own specific use, and so that is the reason we cannot use them in our own customized manner. So let's discuss a look through some of the valid names for variables. So A equals to 5, or B equals to 2.3. These are something similar that we have already seen in the previous slide also. These are some of the short names, and used to store a simple value to it. Then some of the descriptive names, which contains some kind of information, or shows what kind of information the variable might contain. So car name, a bike name with an underscore to represent the space, as space is not a valid character for the variables. Then a capital C in the car name, then also a number 2 added, and or a number added to the name. Then car name starting and ending with the underscore, and also having a number within it, or in a camel case manner, which means that having an uppercase letter within the name itself, and or with every different word, so that a space or spaces cannot be used, but underscore can be. But if you want to avoid, you can use a camel case in order to reflect what the variable means. Then comes the invalid names for the variables in Python. So as we mentioned, the uh, a number cannot be the starting character for the variable name. So one variable is not a valid one. Then my variable with a space containing it. Then my variable separated with a hyphen. And similarly, my variable with an @ sign, then exclamation mark or a $sign. These are all invalid because those contain some of the characters that are not valid according to Python, or is not permissible in Python to be named for a variable. Then, and the first one was a number having being at the start of the variable. Then below are the class, for, and if words that are already in use by Python, and that is the reason that that a user is not allowed to use them with for its own name, because a class, for, and if, they have their own functionality defined within Python. So as we have discussed the rules to get started with the variables, that the variables are used, or they are used to store a value, so that those values can be used whenever it is possible. So the variables can contain different kind of values. So starting with the numbers, how different type of different ways Python can store numbers. So first is the integer values. So integer val is a valid variable name, and storing the value of 5. Then comes the float value, where in programming languages decimal numbers are called float values. So float is used. So float value containing 5.0. Then comes the complex numbers representation in Python. The complex values in Python uh, are expressed in this manner, that the complex value equals to 36 plus 45j. So those are the way that that's how the complex number is expressed. Then coming to assigning and calculating a result using Python variables. So we use variables in order to use them with calculations, or displays their value in certain point, or use them in certain manner, so it can be used. So the variables uh, are used for calculating a result, or displaying something what value they contain. So for the simple example, let's say we are using a variable total, and what does total do? It assigns the summation of a value of number 5 plus number 3. Or what we can do is already have a variable defined a equals to 5 or b equals to 3. And when we assign that summation of a plus b to the variable of total, the total will contain the summation of a plus b, which is 8. Now, there are different ways that you can also assign values in Python. So, uh, you can use multiple ways to assign variable values to the variable. So, you can see that x, y, and z separated by commas is uh, given the corresponding values of red, black, and cyan. So x will be having the value of red, y with black, and z with cyan. Or if you want to give, if many variables have the same kind of same value, then you can assign it in the given manner, which is x equals to y equals to z equals to red, and then all three of them will be having the value of red. Now there is something called unpacking a collection. Now in Python, a collection is many values that can be uh, stored in the collection is called a collection is a group of values in Python. So a list, tuple, and dictionary, which we'll be covering further, are some of the collections in Python that are used. Actually, they are the collections that are used. So when we when we use fruits, which is a variable name of the list, apple, banana, and cherry, that those values can be assigned by the variable in the given manner, that x, y, and z is assigned to fruits, then the values of fruits will be assigned to those variables of x, y, and z. So x corresponds to apple, y corresponds to banana, and z corresponds to cherry. And if we print those values, then we'll get those corresponding results as well. So that is called the unpacking a collection, that we are assigning it to a variable and separating it out in a way. So as we have seen that we have integer value, float value, and complex values that can be stored within the name of the variable. We can also know what kind of variable is a certain kind of variable belongs to. So if we ask what kind of variable or a box are you, if we are following the analogy that we started with, then the variable a equals to 100. So if we ask a, what kind of variable are you, then it will tell us an integer because it contains an integer value within it. So Python will respond with a class int as an output. So these integer values that we have used, these variable values that we have used as an understanding for examples understanding, we can use the type function to recognize the type of the data the variable contains. So trying the type values with the integer values, we'll also summarize what we have covered till now in this one. Uh, can everyone see this screen?
Yes.
It's a Jupyter Notebooks screen.
Yep.
Yeah. Okay. Great. So these were the contents Just a second, let me just zoom it a bit. Okay, so we started our discussion with the basic Python program and what it contains. And we discussed with the variables, its rules, working and with collections, control flow statements, the string operations, functions and methods, maps and filters, modules and packages, list, comprehensions, and lambda functions. Then we started the discussion with variables, as it will be extensively used. Any kind of variable is extensively used within programming languages to store and reuse those values or manipulate those values according to our need. So we discussed the variables and what are the rules for the variables. The short valid variable names were a equals to 5, a and b, c, z, x, y, etc. Then some of the descriptive names in the that can be used. So some of the descriptive names that can be used are car, bike, and stuff, and with the combination of underscore and numbers within it. Then some of the invalid ones are these ones because they contain, the first one contains a digit, the second one contains a space, then hyphen, a sign, uh, or at the rate sign, exclamation mark, and characters, or characters that are not valid in Python for naming conventions in the variables. Then comes the class, for, and if words, that and those are already the keywords in Python and having a designated function to it. So that is the reason that we cannot use it as a variable name. But for the numbers, these are the number. But when we use variable to store numbers, the integer, float, and complex are the types of it, and you can see the integer and its representation can be done in this way. Then comes the float values, then comes the complex values and how they are defined within Python. Then comes how a variable can store a calculation within it. So we used the example of total. So total equals to directly assigning the number and the operation. So we wrote 5 plus 3. If we print it, then it will give us an 8. Or if we write a plus b and have the value of a, say, store the value of 5, or b store the value of 3, then it will give, or any other rate, it will give us the summation of it. So we are storing the total. We are using the variable total to store a value of a summation. Then some of the methods that can be used in order to store the value of a variable in a single line. So x, y, and z are given the value of red, black, and cyan, and separated with commas. Or if we have multiple variables having the common value or a same value, then x equals to y equals to z equals to red, and it becomes a, and when we print it, it gives us the same result. And as discussed before, the fruits is a list which contains apple, banana, and cherry. So these values of apple, banana, and cherry can directly be assigned to a variable like this, where x, y, and z separated by commas and equated to fruits. When we run this cell, then it will give us the value of x is apple. The second statement was on y, so banana, and z for cherry. Then we discussed about the types of the values. So we use the integer value, and when we integer value having the value of 5, it was uh, you can see that we are getting the value of int. The same way, if we use the type function and test it, it will give us the type of value that it holds, the variable holds. So as it contains a float value, it returns a float. Run and test it, then it will give us complex. So just because we have named it over here, it is easier for us to understand that what kind of variable contains what kind of numbers. But sometimes it can be confusing. So this is for that what kind of class does this variable belong to. If we want to print the as you can see the comment that is used to recognize the data type or type of the object. So if we use these same these same type statements within a print statements, these will be the answer for it. So these are basically just written in order to have it have the answers printed in one single output. So now comes the basic operators. So as we have covered certain things within the Python programming, a lot of them are not exclusively taught, but you have already been familiar. Like we started with assigning the values, and then we discussed about it. So the same way we discussed about the addition of numbers too. So these additions, subtractions, divisions, and stuff, those are those are the operations that take place. So Python contains a certain kind of operators divided by their functionalities. So we'll be discussing about the basic operators and the types of operators. So starting with the arithmetic operators, then comparison, assignment, logical, bitwise, membership, identity operators, etc. So starting with the arithmetic operators and addition. Assuming that we are having the value of a equals to 10 and b equals to 21. So addition operator or a plus operator, and it does the addition, adds the value on either side of the operator. So for our example, for the values that we have assumed, we get the answer of 31. For subtraction, it subtracts right hand operand from left hand operand. So a minus b for the values, and we will get the answer of minus 11. Similarly, for multiplication, a into b, and we get the answer of 210 For division, we get b divided by a and get the answer of 2.1. For modulus is a division for left hand operand by right hand operand and returns a remainder to it, not quotient but remainder. So when we divide b modulo a, or we do the operation of b modulo a, we get the remainder of 1. Then comes the exponents or the power power calculation. So a and double multiplication sign into b for the value, and we get 10 to the power of 21. Then comes the floor division, the division of operands, where the result is the quotient in which the digits after the decimal point are removed. But if one of the operands is negative, the result is floored, which means that it is rounded away from 0 towards the negative infinity. So for the example, as you can see, that floor division of 9 and 2 equals to 4, and 9.0 to 2.0 is 4.0. So that is how a floor division is used. Then comes the comparison operators, the lesser than, greater than, whether it's equal to or not equal to and stuff. So comparison operators will start with equals to. So if the value of two operands are equal, then the condition becomes true. So a equals to b is not true, as we have assumed the value of a equals to 10 and b equals to 21. Then not equals to used as exclamation and equals to sign. So a not equals to b is true, as they are not equal. Then comes the comparison operator of greater than, to check whether a value is greater than or not, greater than the other variable. So a greater than b is not true. Then comes the left operand use of a smaller than b is true, as a is smaller than b. Then becomes we can also use the a greater than equal to and a less than equals to. So a greater than equals to b is not true, and a less than equals to b is true. Then as we have used the equals to sign for checking the value of two operands whether it's equal or not, the single equal to sign is used to assign a value to it. So as we have used total in the previous slides for a summation of a and b, here we, instead of total, we have used the variable c with the addition of variable a plus b, and we assign the value summation of a plus b to c. So that is how the single equal to sign is used. Then comes the plus equals to. The plus equals to is nothing but the equivalent of c equals to c plus 1. So c plus equals to a is equivalent to c equals to c plus 1. So rather than making it a longer way, it becomes a shorter way to represent. Then similarly, as we have used c equals to c plus a, we can use c equals to c minus a in as minus equals to sign together. So it subtracts right operand from the left operand and assign the result to left operand. Then the similar is with multiplication. C multiplied equals to a is equivalent to C equals to C multiplied by A. And so is for division, the modulus operator, then the power operator, and the flow division operator. That you can use it with a single equals to sign and the operator of your use with the variable. Now comes the bitwise operator. So now we will be assuming the value of A with 60 and B with 13, and you in Python you have to use the, because we are using the bitwise operator, the binary representation in Python is started with 0B for binary, or if you are using octal then 0O and stuff and so on. So we are using the binary representation. So for A you can see 60 and how 60 is represented in a binary format. So 0B, then 1111 and 00. The same for B. B equals to 13 and it's a binary representation of OB for binary, and then sorry 0B for binary and 1101, and the operator for it. So the ampersand operator, it copies a bit to the result if it exists in both the operands. So A and B will become the 1100. Now these are some of the operands that will see more extensively in the Jupyter Notebooks representation, as it's a verbally or representation way. It might be a bit confusing, but what the ampersand operation does is that it only keeps the common digits and does not calculate the different ones. Then it the second one is it copies a bit if it exists in either of the operands. So you can see the representation of A and B equals to 61 means 0011 and 1101. Then comes the a normally used power character, which copies the bit if it is set in one operand but not both. Then comes the unary operator, which has effect of flipping the bits. So as A is equals to minus 61 means 1100 and 0011 in 2's complements is used, which forms due to a signed binary number. Then comes the bitwise operator for the left and the right operands. So for the first one, the left operand value is moved left by the number of bits specified by the right operand. So A equals to 2 will be represented in this manner, that 11110000. The same is the similar is the operation for the right. The left operand value is moved right by the number of bits specified by the right operand. Then comes the logical operators. Here we will use the value of A equals to true and B equals to false. Now both of these true and false are case sensitive words and should start with capital T for true and capital F for false. So the operator, starting with the AND operator, if both the operands are true, then condition becomes true. So A and B, one is true, one is false. So it is false. But for OR operator, it's different. If any of the two operators are non-zero, then condition becomes true. So if any of them is true, then it becomes true. So here we have A equals to true. So A or B will be equating to true. Then comes the NOT, which is used for flipping the condition uh, onto the other side. So, or to reverse the result or logic. So A and B has the condition of false, but having a NOT wrapped around them will give us true. So it will be reversing the result to it. Then comes the membership operators. The membership operators are used in order to check whether a certain kind of member is within the collection or a variable's value or not. So starting with the in operator, it is used to evaluate true if it finds a variable in the specified sequence and false otherwise. Then x in y, here in results in 1 if x is the member of a sequence y. So if the value that x has, if it is present in the values of y, such as strings, lists, or tuples, then it will result to 1, else it will not. So it basically checks whether the member that let's say you are to find a word in. So if the in word is present in a certain kind of a collection, let's say strings, lists, or tuples, then it will turn out to be 1 as a result, and 0 if in is not present in the string or its values of. Same is not in. So it evaluates true if it does not find a variable in the specified sequence and false otherwise. So if the value of x, whatever word it is, if that word is not present in y, then it will result in 1. And if the value of x is present in y, then it will result in 0. So it's basically a checking manner in order to see if the member is present in the other member in the collection of other variables member or not. So for getting a more clearer idea, let's say we have a list of fruits: banana, apple, banana, and cherry. If so, we will be storing the result banana. We'll be checking the result of banana in fruits. Yes, banana is present. So because banana is present, it will give out true. The same is for the text or a strings example. So we have a variable called result1, and we are checking whether the word exists in the variable text, which says hello world. So word exists in hello world, and so it will say true, and we are printing out the result of result1. Then example for not in. So numbers, we have a list of numbers. So we are checking in the result whether there is number 6 present in the list of numbers or not. And because it is not, it is giving us the result of true. Then comes checking a word in the sentence. So sentence is a quick brown fox, and we are checking the result whether the word dog exists in the string or not. And because it is not, it comes out to be true for the not in statement. Now the identity operators. Now the identity operators, they basically check whether a variable, even if let's say there are two variables A and B, and both of them contain the value 10. Now, programming languages for saving a bit of memory and also becoming efficient at referring back whenever they want to use a memory, certain kind of numbers that are commonly used, they refer the objects into the same place. So even though A and B are different variables, the values of 10 can be a common number, and because it's a common number, it can refer it, uh, the reference for A and B or the address in the memory location of A and B can be same. And the is the is operator or is not operator. These both of them are used to see whether they refer the reference of the variable A and reference of variable B are not same in the memory's point of view. So is evaluates to true if the variable on either side of the operator join point to the same object, and false otherwise. So basically if A and B have the same memory locations or not. So X is Y. Here is results in 1 if ID of X or the address of X in the memory location equals to the address of Y in the memory location. Now the same thing can be checked by is not for a different purpose, for a opposite purpose. Evaluates to false. So is not evaluates to false if the variable on the either side of the operator point to the same object, and true otherwise. So X is not Y. Here is not results in 1 if address of X in the memory location is not equal to the address of Y in the memory location. So so example with the integers first. So A equals to 100 and B equals to 100. Now technically these both of them are different variables, but they do and they also contain same value, but can be stored in a different manner, a different address space. But because of being efficient, the programming languages on the off-stage manner, work for they work in an efficient manner, and so they have some of the common things that can be referred or can be used again and again. Those are used and used for more quick references. So result equals to A is B comes out to be true, not because 100, but because both of them are referring back in the addresses memory location at the same place. So this is called integer caching, as 100 is a comparatively small numbers in comparison to the numbers that are used in real world programs and softwares. So 100 can be used for integer caching. So example with lists, X and Y are lists containing the same numbers. And if we check X is Y, now that will come out to be false, even though 1, 2, and 3 are the values of X and Y, both of them. Because here the entire caching is not done and it's separately created. The list X and Y are separately created as well as stored in the memory location. Now Z equals to a value of X. Now because Z is referring to X and X will be referring to the value that is stored within it, for that reason, X and Y, Z and X, both of them can be pointing to the same address location. And that is the reason why result 11, which is we are using for checking the value of it, comes out to be true, as both of the variables that are stored within the address's memory location, they are referring to the same location. Okay. So, so we referred. So we started with the understanding of the basic operators that are used in Python. The arithmetic operators. The comparison operators, assignment, logical, bitwise, and membership operators, identity operators. So we started with a simple A equals to 10 and B equals to 21, and then a simple arithmetic operator. And for its result, you can see that we are getting the 31. Then comes the subtraction. We are getting the value of minus 11 for our A and B values. Then the multiplication of 210. Then comes the division, and also the modulus operators, which give us the remainder of the division of B divided by A. Then comes the exponent or the power of power operator, which is 2 asterisks. So A to the power of P will give us the result of this. Then comes the floor division, the division of operands where the result is the quotient in which the digits after the decimal point are removed. But if one of the operands is negative, the result is floored, that is the rounded away from the zero towards the negative infinity. So you can see the result over here. Then comes the comparison operators, as if we want to use two variables to compare what is what and stuff. So for that it is used. So first it's A equals to B, whether it's it basically checks whether it is a not or not. Okay, so because A and B, both of them are not equal, it's giving us false. The first equal to operator, which is used to compare the operands. Then comes the not equal to, for checking the values whether it's equal to it or not. Because A and B are not equal to it, gives us true. Then comes the A greater than B operator, and false because it's false. Then comes A is smaller than B operator, if you want to check. And because A is smaller than B, it gives us true. The similar is the condition for greater than equal to and smaller than equal to. So you can see the operation of greater than and smaller than equal to operations. Then comes the assignment of the operator. Assignment operators, as at the beginning we used total as the variable in order to store a calculation. The similar way it can be used here also. And then we used a way to define an operation which is c equals to c plus a. Now this becomes in a way verbose where we can eliminate this c and reverse the order in order to do the same exact thing. And that is the reason we use C plus equals to A, which has the same functionality as C equals to C plus A. And the same logic goes for subtraction. Then comes multiplication, division, the modulus operator, and the power operator, and the flow division as well. Now comes the bitwise operators. So we'll use the 60, and it's a binary format. Okay. 60 and its binary format. The same goes for b equals to 13 and its binary format. So as I mentioned, for representing binary format in Python, you have to use the prefix 0b for binary and 0o for octal and so on. So for representation of A, we use 0b, then comes the binary number for A and B both respectively. And if we check, then you can see the result over here that we're getting the result of 12 for A and B, which means where this is the operator. Then the second operator is this, for which results in 61, and it's a binary representation. The binary is calculated, and the answer to the operation is this, and it's a normal representation is 61, or the result is 61. The same goes for operator as well as this unary operator. Then comes the left left operand shift. So A equals to 60, then A using the two smaller than signs true for 2, it shifts the value of it and gives us the value of 240. The same is for the operand's value is moved to right by the number of bits specified by the right operand. So when we shift it, it becomes the values of it are shifted towards right by 2 values, and hence we are getting the value of 15 over here. Then we discussed about the logical operators true and false, and they should be written with a capital T and capital F. If you write with a smaller case t, it will not, in the Jupyter Notebook or some of the IDEs, it will not show the color. Let's say, for example, if here I have written type true, but if I type true with a smaller case t, it won't change the color because it's an invalid keyword. As I've written true over here with a capital T, and it's a valid one, so that is the reason it's showing in a green color. So now comes the logical operators. If both the operands are true, then condition becomes true, and false as both of them are not true, or both of them are not false, and that is the reason it's giving us false. For or operator, we can have one of the condition is true and it will true, else it needs both of the conditions to be false. Then using the use of the not operator with a and b, as we already know the result of a and b is false, but because we are using a not operator, it is switching or flipping the side to the other side of the result, which is true, and hence we are getting the value of true. Then we checked for the membership operators. So membership operators, they do nothing. Their functionality is nothing but simply stating whether uh, a character or a word exists in a sequence of characters such as strings, lists, or tuples. So let's say we have a string, a fruit, which is collection of strings called apple, banana, and cherry. So for the result, we want to check whether banana is part of the fruits or not. So we can check it with the help of banana is in fruits, and it will result to true. The same way, there is a text called hello world, and we want to check whether world exists in the string text. And when we print the result, first was for banana, as banana exists in the fruits. Then second is for word, as word exists in the text. As we are printing it, it will both be true because they both of them are existing in it. And you can also see it in different manner, in a more general manner, that x in y, any variable x in any variable y, here in results in a 1 if x is a member of a sequence y. Next, checking whether something is not a member of it. So not in. So we have the list of numbers, list called numbers, and then checking whether 6 exists within that numbers or not. Whether 6 not existing within the numbers or not. So 6 not in numbers, and it will result in true because 6 is not part of it. The same way, the string dog is not the part of the sentence the quick brown fox. So that will so it will result true as well. So the identity operators compare the memory locations of two objects, and there are two identity operators that we have discussed, is and is not, as also mentioned before. So as also mentioned before, that identity operators check the addresses, the address where the variables are stored, and see whether they refer to the same address or not. So because A and B refer to the same address, even though they have they are different variables, they can refer to the same address, as it's 100 is a common and a small number, and that is the reason their value will be true. In in second example, we saw the list of 1, 2, 3, and 1, 2, 3 being equated to variable x and y. So x and y containing the value of 1, 2, 3 both, they have the same number, sorry, the same members, but it will result in false because it resulted in false when we printed the result of their comparison, because they both are created separately, and they both of them are given the values separately, and they are not referring back to the same location, and that is the reason that it's resulting in false. Then we are equating the value of z, equating a new variable z to the value of x. And because we are, the x will be referring to its value, and we are assigning another variable z, which is referring to x, and x is referring to its value, it will result in true, because in the end the location at where the address, the value is stored is same, and that is the reason, and that is the use of is and is not. So here you can see that the value that we get for printing the result of these two comparison of a equals to 200, b equals to 200, when we print the result, a is not b, is false. The same way x and y are compared again, stored in the result 22, and then x is not y results in true, because they both of them are not same. The same example that we took for x, z equals to x, if we check it over here, it will come false, because z is referring to the address of a memory address of x. So yeah, this is it for this session. Next, we will be discussing more on the Python's operator precedence and how Python carries the calculations regarding it.
Yeah, Jamie, do you want some exercises for people to try all this? Anything like that?
For
Any
the
books to be referred? Any books referred?
no, this is individually prepared. But if I get the
We have a book referred, right?
this, no, this if I get the resources, then I will give it to the uh, attendees.
So those attendees, please make sure you will get a book once you register. We'll send it to you through the email. Okay. There is a book available, which is available from AICTE.
Okay.
Yeah.
Yeah.
So you will get a book, a digital book, which you can use for the course. And of course, they are not same, but at least you have a reference to follow, and that book you can follow for the course. Okay. So, yeah, Jamie will send, or it will come from info@utf.in. You will get the book, which you can use for learning Python over the next 6 classes. Anything else? Anybody wants to have any questions from anyone? Please feel free to talk if you have anything. Nirmal, Saurabh, or Raghavan, anything? Or Saurabh, who else is there? Sushant and Saurabh, anybody, any questions? Did you follow anything? Did you follow? It was a little bit, what do you call, delayed because of inability to connect. But otherwise, it should be, yeah, go ahead.
Sushant
So,
has some
yes, Sushant, go ahead, ask question. Welcome. Are you muted? Unmuted?
Yeah, one question.
Yeah.
Hope I'm audible.
yeah.
So, how to debug in Juniper? Like, if I want to do step-by-step debugging, I missed that part.
Actually,
Jupyter.
we started directly with Python, but if you want, we can carry a session separate for Jupyter and making notes inside the Jupyter as well. It
Yeah, I think you start next time with Jupyter first.
okay.
How
Okay.
to establish a Jupyter notebook,
So, uh,
download and use it.
I think Saurabh, you asked, right?
Yeah, yeah,
Yeah.
yeah.
So Jupyter can be used from Anaconda or separately as well.
Mhm.
So the way we are using is a separate way, but it's on the attendees how they want to use. You can use it separately from by not using through Anaconda and have a Jupyter setup for your from your notebook and follow up the course.
So hold on.
Yes.
Saurabh, do you have a Windows?
Yes, I have Windows and VS Code also I have.
So your
We
VS Code you can use within VS Code also the code, Python code. But if you want to use Jupyter, then you will have to uh, either you can go over the web and use it, which is available directly in Jupyter. So I'll have to send you the link. Okay. So
okay.
so what we do is those who have attended, we'll
Excuse me,
start.
sir.
Yeah, go ahead.
Excuse me. Yes, now we can also use Jupyter and VS Code too.
Yeah, together.
We just have to download that extension and you can use Jupyter Notebook in VS Code also.
Fantastic. You are the right answer. So Jupyter can be used within VS Code. So I think just a second. Let me share. Let me first stop the recording and then we can do it.